As the population of Malaysia continues to grow, the demand for food is increasing every year. Rice remains one of the most important staple foods for Malaysians and many communities across Asia. Yet, behind every harvest, farmers face growing challenges such as unpredictable weather, crop diseases, and the pressure to produce more food using limited agricultural land. To ensure long-term food security, agriculture must evolve. Modern technologies are becoming essential tools to help farmers monitor crops, make better decisions, and improve productivity. Despite technological progress, many farmers still rely on manual field inspections to monitor their paddy crops. This process is often time-consuming and labor-intensive, especially for farmers who manage large areas of land. At the same time, farmers must also deal with unpredictable climate conditions such as drought caused by El Nino or sudden flooding during heavy monsoon seasons. These environmental changes can quickly affect crop health, water levels, and growth conditions. However, as monitoring is not continuous, problems such as crop stress, disease, or water imbalance may only be detected after significant damage has already occurred. And as a result, farmers may experience reduced crop yields, financial losses, and excessive use of chemical treatments.
Serangan penyakit benar perang memusnahkan tanaman padi di pokok sena Kedah yang menunggu masa untuk dituai.
Masalah itu membelenggu sekumpulan 20 petani yang mengusahakan kira-kira 74 hektar sawah.
Therefore, farmers need a more efficient and reliable way to monitor their paddy fields in real time. And to address this challenge, we have developed SawahSense. Hello and apa kabar? We are Estella from Malaysia, and for this hackathon we have chosen the case study 6, which is AI for food security and education. Our goal is to explore how AI and satellite technology can help farmers make better agricultural decisions and also improve food production sustainability. Basically, SawahSense is a satellite-based paddy field monitoring system which is designed to help farmers to detect crop stress early and also manage their field more effectively. The system analyzes satellite image from the Sentinel-2 Earth observation satellite, and it will be processed by the Google Earth engine. And from this data, SawahSense calculates vegetation indicators such as NDVI, EVI, LSWI that can detect crop health, water levels, and also possible stress in the field. This system doesn't show complex data. Instead, they turn it into simple alerts and recommendations so farmers can easily understand it. We also include an AI assistant called Pak Tani, which farmers can easily ask questions and they will provide clear explanation and guidance about their field conditions. Through this approach, SawahSense supports several United Nations Sustainable Development Goals, particularly SDG 2, SDG 12, and SDG 13. Next, we will demonstrate the SawahSense prototype and show how the system works.
When a new user opens SawahSense for the first time, we don't throw them into empty data. We walk them through 3 simple steps. First, they tell us where their farm is. The map moves to their location automatically, right to their paddy. Step 2, they draw their field. Click around the edges of your field, like tracing it on a map. The system calculates the area automatically, no measuring tape and no guesswork. Step 3, 3 things. What is the field called? What variety is planted? And when was it transplanted? That's it, 3 pieces of information. And with that, SawahSense can now track this field for its entire season, 90 days of satellite monitoring calibrated to this exact variety and this exact start date. This is the dashboard with sample data, 6 fields, 1 season, each one being watched by the Sentinel-2 satellite every 5 days. Green means healthy, amber means something needs your attention, and red means act now. From the Fields tab, you can see every field at a glance, their alert level, their area, and their latest index reading. Most satellite tools only show NDVI, which is the greenness. SawahSense tracks 3 indices because 3 indices catch 3 different problems. NDVI tells you if the plant is green and photosynthesizing. EVI goes deeper. It measures canopy density and structure. It catches nutrient deficiency before NDVI does. LSWI measures water content in the leaves and in the soil. It catches irrigation failure before the plant shows it in color. Let's look at October 20. NVDI heat map Peta C. Deep green looks healthy. Switch to LSWI, same date and same field. Still normal and good soil moisture. But watch what happens when we switch to EVI and look closely at the southeast corner. That wedge, yellow-orange starting exactly at the irrigation water inlet. The satellite caught bacterial leaf blight on October 20th before the farmer could see it on the ground. When the system detects an anomaly, it fires an alert automatically in real time. Let's look at Peta D. NDVI looks normal, EVI looks normal, but LSWI dropped to 0.18, 47% below what it should be at this stage. This points to an issue with an irrigation gate. Water levels dropped and the graph shows exactly when it became abnormal. NDVI showed nothing wrong at all. If you were only using NDVI, you would have missed this entirely, but SawahSense caught it. This is Pak Tani, our AI agronomist built on Malaysian agricultural knowledge, such as Jabatan Pertanian, MARDI, and IADA. Farmers can select from pre-assigned questions based on their field's current status or write their own. Pak Tani doesn't give any generic farming advice. He gives step-by-step guidance based on what your field data actually says, completely backed by official citations. Farmers can also send Pak Tani a photo, a close-up of an affected leaf taken with any phone. Pak Tani analyzes this image and gives a diagnosis right in the chat. Pak Tani also proactively schedules exactly what needs to be done next. The recommendation didn't just stay in a chat, it becomes an actionable task with a deadline and satellite readings attached. From here, the task can be sent directly to the farmer via WhatsApp in one tap. The farmer receives the location, the problem, and exactly what to do. That's one tap from the agronomist's desk to the farmer's pocket. With SawahSense, one click switches the entire UI to Bahasa Melayu, and it can scale to Thai, Vietnamese, or Tagalog. And because farmers work in the field, not at the desk, the whole platform is fully mobile responsive.
SawahSense has strong business potential across ASEAN, where rice farming is affected by drought from El Nino, flooding, and weedy rice, especially in Malaysia, Thailand, and Vietnam. By providing early crop alerts, the system helps farmers reduce losses and increase yield. Our stakeholders include rice industry companies and agricultural agencies. For scalability, SawahSense will expand across ASEAN, add multilingual AI features, and partner with the Ministry of Agriculture and Food Security. Long-term sustainability will be supported through a freemium model, NGO partnerships, and company subscriptions. That is all from Estella, and thank you for watching.